Hey everybody, welcome back. This is Mr. Mack, and Mr. Mack draws. Okay, Mr. Mack's going to draw absolute value of x using derivative analysis. So the first question, of course, is when does absolute value of x equal 0? Well, it equals 0 at 0, but the problem with this one is if I test around 0, which is fine, and the absolute value of 0 is 0, so I know that it's going to be at 0, and the absolute value of a positive number is positive, and the absolute value of a negative number is positive. So this graph is above than above, which is nice. So when I'm graphing this thing, I realize that it's going to be above than above, which is cool. Okay, so next I'm going to see that I'm going to take a derivative, but I'm not really sure how to take a derivative of absolute value of x. So because I can't really, I need to rewrite absolute value of x into the two pieces of the piecewise function that it is. You see, it's negative x when x is less than 0, and it's positive x when x is greater than 0. Because if I'm going to put in a positive number, it's just going to result in x. But if I'm going to put in a negative number, I need it to actually produce the positive result of it. So negative 3 gives me a positive 3, so I need to do the opposite of negative 3 to get 3, which is what I end up getting with my absolute values. Okay, well, regardless of that, my derivative is twofold. My derivative is negative 1 when I'm less than 0, and positive 1 when I'm greater than 0. Okay, this is good. So now what I need to do is realize that there is a break or some sort of piecewise joining at 0. So I always need to test around that, and because it's a potential problem, I'm going to put like a little dashed problem spot. But I know when x is less than 0, my slope isn't only negative, it's actually negative 1. But when I'm to the right of 0, my slope is actually positive 1. Positive 1, not just positive, but positive 1. And then if I take my second derivative, I notice that my second derivative, whoops, messed that up. My second derivative, well, the derivative of negative 1 is 0, and the derivative of 1 is 0, but you can't have a derivative of a non-differentiable point, so I'm just going to ignore at 0, or not ignore, but know that nothing's going on there. But you notice that my slope is always, my slope of my slope, my second derivative, my concavity is 0. When you have a concavity of 0, that means there is no concavity. So there's actually no concavity at all. So now when I do my little sketchy sketch down here, I'm above going down with no concavity, and I'm above going up with no concavity. And because I know that this is linear with the slope of negative 1, I can give it some nice shape, going down the slope of negative 1 to 0, going up with slope of 1 from 0, and there is why absolute value of x looks like it does. Thank you.